Hello friends, Prerna this side from iNeuron. Welcome back to all of you. So we are here for discussing about a new topic, that is geometric progression. So in the previous videos we have discussed what is sequence, what is series, what is progression and what is AP, what is arithmetic progression. Okay, now we are going to find what is geometric progression. We know that in an AP we used to add or subtract something with every term, with every successive term. Okay, we know that common difference for any arithmetic progression is always constant. So they are following a pattern. Every time we are adding a same thing or subtracting a same thing, isn't it? Similarly, we gonna find that what is the pattern that we are going to follow in any geometric progression. So first of all, let us discuss what is GP. GP is actually something like where we have to multiply something like this. Okay, now see what we are doing here. We are multiplying 2 every time, isn't it? We are multiplying 2 every time. Like in AP, we used to add something every time, the same thing. Similarly, in a GP, you have to multiply something every time. So this is the pattern. We can see that in a GP, we are following a pattern in which we are multiplying a constant term with every successive term. So we are here with a formula, that is nth term of a GP is an is equal to ar n minus 1. ar to the power n minus 1. See, what is this? Nth term is ar n minus 1. So if we want to find any term in a GP, we have to use this formula. Now what is a here? We know a is nothing but first term. Like in AP, first term. What is n? The term which we need to find, nth term. Now what is r? R is actually common ratio, just like common difference. Common ratio. Okay, common ratio. So what is common ratio? Common ratio is the ratio of any two successive terms. Like if I want to find common ratio of this progression, then it is 2, 4, 8, and you want to find the common ratio, then you have to divide second by first, third by second, likewise. So it can be 4 by 2 or it can be 8 by 4. Okay, it can be 8 by 4. So what does it mean? It means that if we want to find the common ratio, then we have to divide any two successive term of a given geometric progression. So if you want to find the geometric progression, then you have to follow that the progression is something in which every term multiplied by something gives the next term. Got it? So nth term of a GP is an is equal to ar to the power n minus 1. Now what is sum of n terms of a GP? It is a1 minus rn by 1 minus r. It can be a rn minus 1 by r minus 1. See, this is a formula and this is also a formula. Both are formula for the same thing, sum of n terms, but they are quite different. Why? Because here 1 minus rn and here it is rn minus 1. Why? This formula is applied when r is less than 1, since we are subtracting r from 1, and this is when r is greater than 1. Okay, so it depends that the value of r is greater than 1 or less than 1, then only we can decide that which formula we're gonna take. Okay, now geometric mean. What is geometric mean? The geometric mean of two positive number is under root a into b. Like in AP, arithmetic mean was a plus b by 2, isn't it? Similarly, in GP, geometric mean is under root a into b. Okay, so these are some basic formula of geometric progression which you are going to use. Now let's see what is the relationship between arithmetic mean and geometric mean. Since we are concluding the chapter arithmetic progression, so we have to discuss that what is the relation between these two. So we know that if I have two numbers and I have to find am, then it is a plus b by 2. Similarly, if I want to find the GM, so it is under root a into b. Okay, now what we can do here, A minus G. A is arithmetic mean and capital G is geometric mean. If I'll subtract both of them, it is A plus B by 2 minus under root AB. Isn't it? Now if I'll take LCM, it is A plus B minus 2 root AB by 2. Now see, we can write A as root A square, B as root B square, and it is minus 2 into root A into root B by 2. Now see, this is the formula of whole square. Can we write it like under root A minus under root B whole square by 2? Can we write? Yes. So A minus G is nothing but under root A minus under root B whole square by 2. Since it is a square, it is greater than 0. Obviously, if it is a square, it will be greater than 0. So we can write, I am writing it here, we can write A minus G is greater than 0, which means A is greater than equal to G. It proves that arithmetic mean is always greater than or equal to geometric mean. Got it? Okay. So this is the relation between arithmetic mean and geometric mean. Okay. So now we are going to discuss exercise 9.3 about geometric progression, in which we will discuss all the possible questions related to geometric progression. So let's start from the question number 1. Question number 1 says, find the 20th term and nth term of the GP. This. Okay. So you have to find A20, AN, and the GP is 5 by 2, 5 by 4, 5 by 8, and so on. Okay, so like in AP, we need to find A, N and D, isn't it? A, N and D. Similarly, in this exercise, we are going to find A, R and N. A, R and N. So in place of D, we are going to find R. So what is A here? We have 5 by 2 as the first term. Now, if I want to find the ratio, then I have to divide 5 by 4 by 5 by 2. So it is 5 by 4 into 2 by 5. So it is 1 by 2. So it is 1 by 2. Okay. Now we need to find A20. So according to the formula, it is AR20 minus 1. A is nothing but 5 by 2. R is 1 by 2 to the power 19. Or I can say 5 by 2 to the power 19 plus 1, 20. If the power is more than 10, then you don't need to multiply it 20 times or 15 times. Okay, so you can leave it here. Now similarly, if I want to find nth term, then it is ARN minus 1. What is A here? 5 by 2. What is R here? 1 by 2 to the power n minus 1. Okay, so here it is 5 by 2 into 1 by 2 to the power n minus 1. Can we write it like this? 1 to the power anything will remain 1 and 2 to the power n minus 1 at the denominator. Now it is n minus 1 and we can add it. So it will give 5 by 2 to the power n minus 1 plus 1. So it is n only. Okay, got it. So this is question number 1 of exercise 9.3. Moving on to next question, that is question number 2. Question number 2 says, find the 12th term of a GP whose 8th term is 192, and common ratio is 2. Okay, so find the 12th term. You have to find the 12th term of a GP whose 8th term is 192 and common ratio is 2. So this is the complete data given in the question. Now see, we have 8th term 192. See, AR 8 minus 1 is equal to 192 and we have the value of R, which is 2. So A into 2 to the power 7 is equal to 192. So it is A is equal to 192 by 2 to the power 7. Okay, so it is so it is 3 by 2. A is equal to 3 by 2. Okay, now what we have to find? A12. So A12 is AR12 minus 1. So A is 3 by 2. Sorry, A is 3 by 2. R is 2 to the power 11. So actually 3 into 2 to the power 10, isn't it? 11, and if I subtract 1 power, then it will give 3 into 2 to the power 10. Got it? So this is the question number 2. Okay. So moving on to next question. I hope it is clear to all of you. Moving on to next question. Next question says, the 5th, 8th and 11th term of a GP, the 5th, 8th and 11th term of a GP are P, Q and S respectively. Show that Q square is equal to PS. Okay, Q square is equal to PS. So the question says 5th term is P, or we can say AR to the power 5 minus 1, that is 4, is equal to P. This is equation 1. Now 8th term. 8th term is Q. AR 8 minus 1, that is 7, is equal to Q. Okay. And the third thing is 11th term is S. 11th term is S, which means A into R to the power 11 minus 1, that is 10, is equal to S. This is equation 3. Okay, this is the complete data given in the question, and we have to prove that Q square is equal to PS. Okay, so first of all, if I am dividing 2 by 1, 2 divided by 1, what it will give? AR7 by AR4 is equal to Q by P. So it is R to the power 3 equal to Q by P. Okay, let us suppose I am dividing 3 by 2. 3 divided by 2. So equation 3 is AR to the power 10 by AR to the power 7 is equal to S by Q. Again, it will give 10 minus 7, R cube is equal to S by Q. See, from equation 4 and 5, we have a value of R cube, Q by P and S by Q. So, from equation 4 and 5, from equation 4 and 5, we can say Q by P is equal to S by Q. On cross multiplying, it will give Q square is equal to PS. This is the thing that we need to prove. Got it? Clear? So very easy it is. So in AP, we used to solve two equations which were in A and D. And in GP, we will divide the equations. Okay, so this is the basic difference while solving question based on GP. Now, the fourth term of a GP is square of its second term. Okay, is means equal to square of its second term. Okay, and the first term is minus 3. A is equal to minus 3. Okay, now determine its seventh term. You have to determine its seventh term. Got it? So the thing is, fourth term is AR4 minus 1 and it is AR2 minus 1 and 2. AR cube is equal to AR and then square. AR cube is equal to A square R square. Okay. Now see, we can cancel out these things and R square with 2R. So it is R is equal to A and R is equal to minus 3. That's it, since A is equal to minus 3. So A is minus 3 and r is equal to a, then r is also minus 3. Determine its seventh term. Determine its seventh term. So seventh term is AR7 minus 1, which is AR6. Now A is minus 3 and R is also minus 3. So it is minus 3 to the power 7. 6 plus 1, 7. Now you can multiply it or leave it like this. Both are correct. Okay. So next question. Question number 5. It has two parts. I think 3 parts. Yeah. So which term of the following sequence is this? Okay. So the first question is 2 root 2 and 4, and you have to find that in this GP which term is 128, which means 128 will come at which place. So let us suppose that the nth term is 128. So you have to find the n. Now the formula for nth term is ARn minus 1 is equal to 128. Now what is the value of A here? I am writing it before. Value of A is first term and R is second minus, second divided by first. Okay. So it is root 2. Okay, so it is root 2. So A is 2. The value of R is root 2 to the power n minus 1 is equal to 128. So it is root 2 to the power n minus 1. Okay, now you have to see that this is 2 to the power 6, I think. 2 to the power 5 is 32. So 2 to the power 6 is 60. So it is root 2 n minus 1 is equal to root 2 to the power 12. If it is 2 to the power 6, then root 2 to the power 12. So n minus 1 is equal to 12. So n is 13. 13th term is 128. 13th term is 128. Okay, so moving on to next part. Next part is root 3, comma 3, 3 root 3, like that. So here first term is root 3. Common ratio is 3 by root 3. Sorry, 3 by root 3. We can write it like root 3 into root 3 by root 3. Can we write 3 as root 3 into root 3? So R is nothing but root 3. Now we have to check that 729 will come at which place. So nth term is 729. Nth term is 729. So it is AR n minus 1, 729. Now what is A? A is root 3. R is root 3 to the power n minus 1 equal to 729. This is 3 only. Okay. Now see, we can write root 3 to the power n minus 1 plus 1. That is n only. And here it is 729. So 729 is so it is 3 to the power 4. 3 to the power 4 plus 2. So 3 to the power 6. So we can write it root 3 to the power double. 6 to the 12. So n is equal to 12. So this is the answer of part B of question number 5. Okay. So moving on to next, that is C. So C says 1 by 3, 1 by 9, 1 by 27. Okay. And the nth term is nothing but 1 by 19683. Okay, so the formula is AN is equal to AR n minus 1, isn't it? So A is 1 by 3 and R is 1 by 9 by 1 by 3. So it is 1 by 9 into 3 by 1. So it is 1 by 3 actually. Okay, so we have the value of A and R here. So A, R, N minus 1 is equal to 1 by 19683. Okay. So it is 1 by 3 to the power n minus 1, and you have to check 1 by 6561 is how much. So 6561. A 1, 2, 3, 4, 5, 6, 7, 8. So it is 3 to the power 8. So n minus 1 is equal to 8 and n is equal to 9. Got it? Okay, moving on to next question, question number 6. Question number 6 says, for what value of x, for what values of x, the numbers minus 2 by 7, x and minus 7 by 2 are in GP. If they are in GP, then common ratio for each pair of consecutive term will be same. So common ratio can be x by minus 2 by 7, okay, or common ratio can be minus 7 by 2 by x, isn't it? Since common ratio remains same, so we can say x by minus 2 by 7 is equal to minus 7 by 2 by x. Now if I cross multiply it, it will give x square is equal to minus 7 by 2 into minus 2 by 7. So x square is equal to 1. So x can be 1 or minus 1. Isn't it? Since if we find the square root, it can give 1 or minus 1. So the values of x are 1 or minus 1. Got it? So moving on to next question, question number 7. Question number 7 is, find the sum to indicated number of terms in each of the geometric progression in exercises 7 to 10. So we have to find the sum till 20 terms. Okay, so here we have A as 0.15. 0.15. Okay, what is R here? R is 0.015 by 0.15. So if I'll remove this, it will give 100 at the numerator, and if I'll remove this, it will give 1000 at the denominator. So it is 1 by 10, or we can say 0.1. So common ratio is nothing but 0.1. Now you have to find S20. S20. You have to find S20. Now we have the value of R which is less than 1, isn't it? So which formula we are going to take? Sn is equal to A 1 minus Rn by 1 minus R. So A is 0.15. A is 0.15. 1 minus the value of R is 0.1 to the power n, which is 20 here, since we are finding sum of 20 terms. So 20, and at the denominator we have 1 minus R. So it is 0.15 into 1 minus 0.1 to the power 20. Okay, so it is 1 by 10 to the power 20, and at the denominator it is 1 minus 0.1. So it is 0.9 only. So it is 0.9. See, we can write it 15 by 9. Okay, for 9 we are putting 10 here, and for this point we are putting 100 at the denominator. Okay, now Now see, we have 1 minus 1 by 10 to the power 20, or we can say 10 to the power 20 minus 1 by 10 to the power 20. Simple. Okay, so we have 1 by 6. Okay, 10 to the power 20 minus 1 by 10 to the power 20. You can leave it here. Okay, so this is the answer. Next question is question number 8, and we have to find sum till n terms. Okay, so here A is, first term is root 7. Common ratio is root 21 by root 7. It is root 3 only, isn't it? Now what is Sn? The value of root 3 is something in positive, so we will apply a Rn minus 1 by R minus 1. So it is a root 3 to the power n minus 1 by root 3 minus 1. So you should simplify it by rationalizing it. What is the value of a? Root 7. So we should put the value root 7 under root 3n minus 1 by root 3 minus 1, root 3 plus 1, which means it is root 3 square minus 1 square. So it is 3 minus 1, that is 2 only. So it is 2 here, and root 3 plus 1 at the numerator. That's it. That's it. Okay. I hope it is clear to all of you. It is very easy. In the next question, question number 9, it says 1, comma, minus a, comma, a square, comma, minus a cube, comma, dot, dot, dot. Now, a is 1 and common ratio is minus a by 1, or you can say minus a. So for finding sum of n terms, we will use a, since it is negative. So we should use 1 minus Rn by 1 minus R. Okay, so it is a is 1 minus a to the power n by 1 minus R, that is minus a. Okay, so it is 1 minus a to the power n, and at the denominator we have 1 plus a. That's it. Since it is not in square root, so you can leave it like this only. So question number 9 is over, and the next question is question number 10. Question number 10 says x cube, x to the power 5, x to the power 7, and you have to find n terms. See, the question was find the sum to indicated number of terms, this thing. Okay, in each of the geometric progression 7 to 10. Okay, so we are in 10 only. First term is x cube. Common ratio is x to the power 5 by x to the power 3. So it is x to the power 2. Got it? Now, Sn is equal to Arn minus 1 by R minus 1. When you don't know the value of R, which is a variable, or you don't know the value of R, then you can apply this formula only. So Sn is equal to x to the power 3 R to the power n, that is x square to the power n minus 1 by x square minus 1. That's it. Okay, you don't need to solve it. That's okay. Now moving on to question number 11. Now this question is quite different. It says evaluate summation k equal to 1 to 11 for the function 2 plus 3k. So this is the question. It means that you have to put the value of k from 1 to 11 in this expression. So if I'll put the value of k as 1, it will give 2 plus 3 to the power 1. Summation means sum. Okay, sum. Every time you have to add. Then again 2 plus 3 to the power 2. Then again 2 plus 3 to the power 3, and you will go on like this, and at the end it is 2 plus 3 to the power 11. So this is the complete data given in the question. Now see, we have added 2 11 times. So if I'll write 2 plus 2 plus 2 11 times, so it is nothing but 2 into 11, that is 22. And after that we have 3 square, 3 cube, and at the end we have 3 to the power 11. Okay, so we have 3 to the power 11. So what is it? It is a GP. So we will apply the formula of sum of n terms in a GP. So A is 3, R is 3 to the power n. What is n here? 11. We have 11 terms. Rn minus 1 by R minus 1. So it is 3 by 2, 3 to the power 11 minus 1. You have to solve this. You will solve it and then add with the 22. That will give you the answer. So this is the format in which we can write a question given in summation. If it says summation, which means you have to put these value 1 to 11 in the given bracket. That's it. And after that you can see that it is an AP or GP or whatever. You can apply the formula. Now see, the question number 12 says the sum of first 3 terms of a GP is 39 by 10. Okay, so sum of 3 terms is 39 by 10 and their product is 1. So like in AP, if the sum and product is given, then you have to consider 3 terms. So I am considering, let the 3 terms of a GP be A by R, A and then AR. You can find the common ratio and you can check that common ratio are same or not. Now see, question says product of these 3 terms is 1. Okay, so A by R into A into AR is equal to 1. So it is A cube 1, or I can say A cube is equal to 1 cube. A is equal to 1. Now we have the value of first term. And it says sum of these 3 terms. Sum of these 3 terms. It is A by R plus A plus AR. It is 39 by 10. Now we can take A common. It is 1 by R, 1 R, 39 by 10. Now the value of A is 1. So it is 1 plus R square by R is equal to 39 by 10. Now if we cross multiply it, it will give 10R square plus 10R plus 10 is equal to 39R. Is equal to 39R. Got it? Now it will give 10R square minus 29R plus 10 is equal to 0. Okay, I'm solving it here. Okay, so we have 100 and we have to factorize it. Okay, so it is 25 and 4 will give 29. So it is 10R square minus 25R minus 4R plus 10 equal to 0. So it is 2R minus 5, 5R minus 2. Okay, so the value of R can be 5 by 2 from this and 2 by 5. So we have R which can be 5 by 2 or 2 by 5. Okay, now the GP can be, if I'll go through this, if A is 1 and R is 5 by 2, okay, then GP will be A by R, this by this, 1 by 5 by 2, 1 by 5 by 2, comma 1, comma A into R, 1 into 5 by 2. That is 2 by 5, 1 or 5 by 2. Okay, so this can be a GP, or if I'll take A as 1 and second value of R, that is 2 by 5. That is 2 by 5. Okay, so it is A by R. Okay, A by R comma A into R. So we can say 5 by 2 comma 1 comma 2 by 5. Okay, so this can be answer, this can be answer. Both are same, only difference is the order. Okay, so this is the complete solution of question number 12. I hope it is clear to you. When the question says that sum is this, product is this, then you have to consider these three terms only. Okay.